So now we move on to the next material, biomaterial, that is your metallic biomaterial. We all know that metals are again very commonly known, well known, and we cannot just ignore their importance, mainly because of the strength which they can offer. So this metal and metal alloys are used for medical requirements, especially which are used are your stainless steel. In stainless steel metallic biomaterial, we use 316L, titanium and alloys, chromium alloys, aluminum alloys, zirconia, niobium, tungsten heavy alloys. And then where are they used? They are used in dental implants, craniofacial plates and screws, artificial hearts, pacemakers, clips, valves, balloon catheters, medical devices, equipments, bone fixation devices, dental materials, medical radiation shielding products, prosthetic and orthodontic devices. So they have a huge range of applications, and all these pictorial representations are predominantly aimed in strengthening the skeletal system, most of them. So, and we have other applications as well. The advantages as well known is that they offer a huge advantage of strength. So, the mechanical properties which they are offering is very, very high. So, they are they are biocompatible. The only disadvantage is they are not bioactive, they are biocompatible, and there is good corrosion resistance in alloyed metallic alloys. There are good corrosion resistance as well. So, as the material becomes more stronger, as the material becomes more with high strength, it can be used in applications of load bearing regions. We know that the hip jaw bones, the entire body weight is actually resting on the long bones of the legs. So, the hip bones are the ones which require a lot of strength, and not only the hip bones, we have the femur, the tibia, all the leg bones, legs and hip are the ones which require most strongest material to be replaced. So, metals play a very big role in that, and for load bearing regions the metals preferred are your cobalt, chromium, molybdenum alloy. So, that has to be remembered. So, how are they useful? They have a very high tensile strength and fatigue limit of the metals, because they can carry huge mechanical loads when compared to ceramics and polymer materials. So, in comparison, polymer, then ceramics, and above all your metals are the ones which would give very high tensile strength. And further, these metallic biomaterials, the most commonly used or the preferred ones are your titanium alloys also, in addition to cobalt, chromium alloys. The advantage of titanium based alloys is that they are more light weighted, and as it is more light weighted, the difficulty in carrying the implant, if it is going to be a larger replacement, then it becomes more easy for the patient. So, it is advised to use titanium, or titanium is more preferred than even cobalt and chromium. So, again, as already mentioned in the pictorial representation, the application of these metallic biomaterials mostly relate to bone and bone replacements mostly. And again, the most common ones cannot be forgotten. So, and the stainless steel metal biomaterial has to be known. Stainless steel again is widely used. The name stainless steel is derived because it has very high corrosion resistance because of the low carbon content and the percentage of chromium. So, this particular composition makes stainless steel a more sought after material, more sought after biomaterial. Addition of molybdenum to this particular alloy makes it even more stronger and more durable. And stainless steel, the moment we read stainless steel, we need to quickly understand that stainless steel exists in three forms: austenite, martensite and ferritic stainless steel, based on their crystallographic structures. Study on metals does not get complete without reading these crystallographic structures. So, we have the face centered cube, that is austenitic phase, body centered cube, that is your body centered crystallographic structure, that is the ferritic, and then we have the face centered tetragon, the martensitic. A quick look at the tabulation over here. So, ferritic is your body centered, austenitic is your face centered, and martensitic is the face centered tetragon. And these are different. The crystallographic structures are different here because of the composition present here. So, martensitic stainless steel has a content of 12 to 18%. Here it is 12 to 25% of chromium in ferritic, and then we have martensitic again, austenitic martensitic, it is 13 to 16%. So, what are the advantages of stainless steel? Stainless steel, the most important advantage is the oxygen contributes, there is a self-healing protective layer on the surface of the steel, and it can also be further modified, the surface can be further modified by a variety of methods like plasma assisted, low temperature nitriding, carburizing, carbonitriding and so on, which will enhance the corrosion resistance. And the other important things are, it can be actually important factor is that the medical use of stainless steel is almost similar to cobalt, chromium and titanium based alloys. To that extent, though it is cost effective, it is equivalent to these two alloys. The disadvantage of stainless steel is that we know that there is a particular percentage of nickel inside, and this nickel toxicity, if the host is nickel allergic, then it cannot be used. So, this makes it toxic to the host tissue, and in addition they are also vulnerable to pit and crevice corrosion and stress corrosion cracking. And further we have the cobalt chromium alloy. So, these cobalt based alloys or your cobalt chromium are most pervasive and superior to stainless steel, and as already mentioned, it is used in load bearing areas. So, we can see that this is the hip joint and this is the socket. So, this is the ball and socket, and then we can see that it can also be used as reinforcing agents in the stent tubes, and we also use it as cast partial frameworks in denture placements. So, it is got that extreme extreme strength, extreme tensile strength, and very favorite material to be used by orthopedicians and dental surgeons. And then we have titanium and titanium based alloys. As already mentioned, titanium is the most sought after material because of its biocompatibility and because of its light weight. You can see the pictorial representation, there is again a huge list of applications over there. The most frequently represented titanium based biomaterial is used in dental implants. We know that dental implants are being very widely used nowadays for replacement of missing teeth, and in addition it is also used as heart valve replacement, it is also used as the rib gauge replacement because they are very light, and in case if there is a fracture it can be used as a bone replacement agent, and then it can be used as a plate, it can be used as a joint, it can be used as a pacemaker, as a stent. So, because of its lightweightedness and biocompatibility, resistance to biocorrosion. So, this is the most highest biocompatible material or the most sought after biomaterial in relation to the term biocompatibility. So, having said that, we need to understand that commercial titanium is available in 4 grades. So, while choosing titanium, you will have to choose between the grades of titanium based on how much of the alloy molecules are there. So, depending on that, the characteristics of titanium would differ. And then further we have the noble metal alloys, which has been there in practice from prehistoric times. So, gold and silver have been in use for very long times as the human mankind can remember. So, high noble alloys are your gold platinum, gold palladium, gold silver, copper, gold platinum alloys. They are very frequently used because of their high durability, stability and excellent corrosion resistance, and they are considered noble because of this excellent corrosion resistance. So, metallic biomaterials in general do not possess bone conductivity, and if the material has to be made as a biofunctional element, there has to be an additional bone conductivity and bone activity which has to be added. So, these gold alloys are already known that they are very durable and they are corrosion resistant, and they are actually used as a filling material. So, when they are used as a filling material, they can either be casted and then fitted onto it, or they can be malleted onto the defective area where they can be used as a filling material. Corrosion resistance again is very high for gold, but if the amount of gold is below 75%, then the corrosion resistance decreases. Then we further have silver and silver alloys. The moment we speak of silver, the most important agent is the antibacterial, antiviral agent, which is why silver is more preferred. So, silver nanoparticles are very widely used in wound dressing materials because of this antimicrobial properties. And in addition, it is also used in dentistry, in endodontics, dental prosthesis, implantology and restorative dentistry. It has a very high antimicrobial effect and it is being implemented where and where necessary. Silver compounds, especially silver nitrate, is actually even used as a caries preventing agent, as a solution applied on the teeth substance, caries tooth, and so that there is no further recurrence of caries, and it is used as a cavity sterilizing agent and a dentin desensitizing agent. The only disadvantage of silver nitrate, as for the properties mentioned above, is that it would cause severe discoloration. Otherwise, for its potent antimicrobial action, it would really serve as a very good cavity sterilizing agent. And then further we have dental amalgam consisting of liquid, mercury and a powdered alloy composed of silver, tin and copper. And then further we have shape memory alloys. So, these shape memory alloys are very important. So, those are the alloys which have the potency to remember their shape memory as what was before and what was there after deformation, and then quickly coming back to its original state. So, this shape memory describes the ability of a material to be plastically deformed below its transformation temperature and then bounce back, recover back to its original shape. So, this particular shape memory alloys, the examples of shape memory alloys, the ones which we use in dentistry is NiTi. In addition, there are many shape memory alloys which are your silver caladium, gold caladium, and then you have copper, aluminum, nickel, copper, aluminum, beryllium, we have copper tin, copper, zinc, copper, tantalum, and then we have nickel, aluminum, ferrous, platinum, and then we have ferrous palladium or iron palladium, manganese copper, ferrous manganese silicon. Shape memory alloys happen, or the phenomenon of shape memory happens because of its ability to shift between the martensitic, from the austenitic to the martensitic and then further back to the austenitic phase. We read in stainless steel that generally metals are available in three forms. So, we saw the crystallographic structures, how we have a face centered and a body centered and a tetragonal structure and so on. So, those are the austenitic structures, and so one from there, if it shifts back, it can revert back to austenite. So, austenite phase is actually stable at high temperatures, whereas martenitic phase is stable at low temperature of low symmetry. So, when there is again a change, then it reverts back to its austenitic phase. And where and how are these shape memory alloys used? They are of great use in orthodontics, where we have wires which have shape memory effect, and that is of great use to align malaligned tooth. It can very quickly correct as the shape of the archwire and can bring it into perfect alignment. And then we also have it in orthopedics, vascular stents. So, those where you have a blocked artery or an atherosclerotic plaque, if there is anything, the stent which has a shape memory alloy can be pushed into, and then it can be altered accordingly where and when required. It also has numerous efforts here in neurosurgical field, where it can be used as a coil, stent and micro guide wires, which are very crucial for neurosurgery, because we know that neurosurgery is such a very critical technique sensitive procedure which involves the most sensitive part of our human body, the human brain, where the wires have to be really small. At the same time, it should quickly bounce back to its normal size.